Hour 2 on the big payments repository, and Marco asks the reviewer why the refund path validates twice. It says services of this kind typically validate at the boundary and then again before the write. Typically, it read that file 40 minutes ago and now it's describing a pattern instead of the code. He asks again and gets a different answer. Both plausible, neither one tied to a line in the repository. Nothing crashed, no error came back, and this reviewer was excellent on a small repository this morning. Freeze it right there, because that vague answer is an exam question, and here is how it gets asked. An agent explores a large code base over a long session, and late on it answers from typical patterns instead of the code it read. Which mechanism keeps the specific findings? That's the failure with no error message, and it lives in the smallest domain on the exam. Domain 5, context management and reliability, roughly 9 of the 60 questions you'll set. It owns 2 task statements, preserving critical information across a long interaction and managing context in a large code base. By the end, you'll know which of 3 mechanisms a problem needs, and most people think there's only one. The architect question parked in the corner all episode is the last of the 4. What survives? Start with the window, because all 3 mechanisms are fighting over it. It holds the system prompt, every message you send, and every tool result, image and document that comes back. It holds your tool definitions too, and the turn's own output, thinking included. A bigger window doesn't buy a better answer, because as the token count grows, accuracy and recall degrade. The documentation has a name for that slow decay, and the name is context rot. That's Marco's morning and Marco's afternoon. Same reviewer, same code, and the only thing that changed was how full it got. So match the window to the workload and treat it as a budget you curate. 3 mechanisms do that curating, and telling them apart is most of this domain. This is the part most preparation gets wrong, so it's worth going slowly. The first is compaction, and it's the platform's primary strategy for a conversation that runs long. It runs on the server, it fires when the input crosses a token threshold you configure, and it replaces the history with a summary. So one verb carries compaction, and the verb you want is summarize. The second is context editing, and it doesn't summarize anything at all. It clears blocks instead. The stale tool results a long run piles up, and the model's own thinking blocks. So one verb carries context editing too, and the verb you want is clear. Those two sit under the same context management setting, and that's exactly why people take them for one feature. The third is memory, and it's a different category of thing. Compaction and editing shrink the conversation you're already inside, and memory outlives it. You declare memory as a tool. Claude asks for file operations, and your own application performs them. One verb for memory. It persists. Compaction keeps the active context small, and memory preserves what has to survive summarization. That second half is the line this whole episode turns on. If it has to survive, it can't live in the history. 2 of the 3 ask something of your code in return, and that's where implementations quietly break. Compaction asks the most, so start there. The response comes back with a compaction block inside it, and you pass that block back on the next request. From there, the API ignores every content block before it, so that block is the seam in the conversation. The bug's easy to write. You append only the text. Everything keeps working, and the compaction state quietly disappears. So append the whole response content. Context editing asks nothing of you because the server applies it before the prompt reaches the model, and your client keeps the full history. Memory plans for it instead, because the API injects a protocol as soon as the memory tool is in your tools. That protocol tells Claude to read its memory directory first and to assume its context can be reset at any moment. That's the platform half of this domain, and the other half isn't a platform feature at all. Here is the half nobody prepares for. All 3 of them compress something, and compression is where the specifics go. The guide's blunt about it. Amounts and percentages and dates and what a person actually said get condensed into something vague. On this system, it's the same shape. The invariant Marco stated at the start comes back as there were some validation concerns. So stop letting those facts live in the history and extract them into a block of their own that goes into every prompt. That block sits outside the part that gets summarized. So whatever happens to the narrative, those lines survive in full. That's the rally line doing real work. If it has to survive, it can't live in the history. A model handles the start and the end of a long input reliably, and it drops findings out of the middle. So put the key findings on top with section headers down the detail below, and trim a verbose tool result to the fields that matter, because a lookup hands back every field when a handful are relevant. All of that keeps the facts alive inside the conversation, and the strongest move takes them out of it. Back to Marco's repository, where the guide describes his symptom exactly. In extended sessions, the model answers inconsistently and starts referencing typical patterns rather than the classes it found earlier. Typically, that's the same word printed in the blueprint. The move is a Scratchpad file, and the agent writes its key findings into it as it goes, then reads it back before answering later. Every line in there carries the path it came from, and that's the part that matters. A remembered finding and a recorded one look identical until somebody tests them. Delegation comes next, and it sends the verbose reading into a subagent while the main agent keeps the high level picture. The subagent spends its context on the file contents and hands back a short answer, so the main window stays clean. Summarize a phase before the next one starts and inject that summary into the opening context of the next phase. And Claude Code has a compact command for a session that's already filled with verbose discovery output. One mechanism left, and it's the one candidates reach for when they should be reaching for a notebook. Prompt caching is the last piece, and this exam treats it as a fact about structure, not cost. A cache matches a prefix built in a fixed order, tool definitions, then system, then messages. Each level builds on the one before it, so a change at one level invalidates that level and everything after it. Change a tool definition and the whole cache is gone because they sit at position 0, so stable content goes first. Now the fact worth memorizing about caching and the context window. A cached prefix still occupies the window, so caching changes what you pay for those tokens, not whether they count. Verify it in the usage fields, because there is a per model minimum prefix length, and under it caching silently doesn't happen. That's every mechanism in the domain. Here is an item with 4 of them in front of you. A note first, because the guide's own samples cover only 4 of its 6 scenarios, and developer productivity is one of the 2 with none. So this item is authored, not published. An agent explores a large monorepo across a long session using the built-in reading and searching tools. Late on, it answers from typical patterns instead of the classes it read, and the same question gets 2 different answers. The requirement is that a question about the refund flow must never be answered from a general pattern once the code's been read. Option 1. Move to a model with a longer context window so the whole exploration fits at once. Option 2. Add a line to the project instruction file telling it to stay consistent with what it established earlier. Option 3. Turn caching on over the exploration history so the earlier findings stay available cheaply. Option 4. Every phase writes its findings and their paths into a Scratchpad, and it reads that Scratchpad before answering. The verbose file reading gets pushed down into subagents too. Name the question first. It's about what the system still knows late in a long run, so it's asking what survives. Then find the absolute. The stem says must never, so the line in the instruction file dies where it stands. Guidance can't promise you anything about hour 2. The longer window goes next, because accuracy and recall degrade as the window fills, so it buys a longer runway to the same failure. Caching goes on the fact you just memorized, because a cached prefix still occupies the window. Option 4 is the only one where the finding leaves the context and can be read back afterwards. If it has to survive, it can't live in the history, and that's the answer. Look at where the system stands tonight. reviewing a large repository without losing what it established early on. The facts it has to keep no longer live in the part that gets summarized, and the verbose reading happens inside subagents. Findings land in a scratchpad with the paths they came from, and the conversation gets compacted on purpose. You can name which of the three mechanisms a problem needs and say why the other two wouldn't have fixed it. One line to walk into the exam with: if it has to survive, it can't live in the history. Then Nadia opens the exam guide, finds the situations the whole exam is built from printed inside it, and nobody has read them.